Hello, everyone. I'm here today to uh, share with y'all Quicksort. Um, my name is Noah Larson, and so here we go. Um, so the purpose of Quicksort is to order elements in a list or array. So basically, it takes a list or array and sorts it the way that you need it sorted. Sorry. So basically, Quicksort uses a method called divide and conquer. So what it does is it divides the list or array in half with a pivot point. So it picks a pivot point and then it starts to look at each element in the list or array and see if it's greater or less than the pivot that has been chosen. If it is greater, it goes to the right of the pivot, and if it's less than, it goes to the left of the pivot. And it continues to do this, and it's what we call recursion to find new pivots in each of the new list or arrays that is created on the left or right of the original pivot, and continues to do this until the list or array is sorted, and then combines all those lists and arrays it made back together. So the performance of Quicksort, so for best case, it's omega of n log n, and as well as average case of theta n log n. And the worst case is n squared. And now the worst case is basically you have to sort through basically it's backwards. So if you're doing numbers 1 through 10, 10 is first and 1 is last. And it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And you have to resort everything to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the average and best case uh, means that things are a bit closer to where it needs to be, basically, and you don't have to sort through everything. Sweet. So that's the presentation. We're going to look at some code now. So let me switch screens real quick. Doo -doo -doo -doo. All right. So over here we have the quick sort algorithm in C#. So right here we have the sort function. And so it calls the underscore sort function with the data from the list, and it starts at 0 is the first, and then the length of the list minus 1. And so here the sort function, so if the first is greater than the last, return. That means the sub list size is 0 or negative and does not need to be sorted anymore. Otherwise, we will find the pivot index using the partition function, and then we'll recursively sort the left sublist and then the right sublist. So the partition, it basically selects the last value as the pivot and initializes the leftmost pointer using the LMPG. So if the index of the list is will be the first point, and the index is less than the last, and then we'll go through every number basically. So if the index is less than the pivot, we will swap it and put it to the left, and then increase the pointer counter. And then if it isn't, we'll move it to the other side, and then we'll return the pivot index. Sweet. So what I decided to do is to use this algorithm to basically sort all the Pokemon's names that have been created. So basically the main one, it calls the fetch Pokemon names, and then it sorts the Pokemon names list, which is getting created here. And then for each name in Pokemon names, it will write the name. So, and then this function right here, it basically does the API requests and creates the list for us. And then this is just to be able to call the JSON from the API requests and look for specifically the Pokemon name. So if we run it real quick, and if we look at this list, scroll all the way to the top, there's 1,025 Pokemon, so this is a really long list. You disappear, thank you. So, as you can see, it is sorting in alphabetical order all the names of the Pokemon. And it is a really long list, but you can see that it's all organized when you look at the letters. It's a huge list of Pokemon. Sweet. There we go. Thank you so much for watching, guys. Really appreciate it. Um, just remember, Quicksort is all about organizing lists, and we can use it for anything. We can use it for numbers or names, and if you want, you can probably switch it around if you want it to go from Z to A or highest to lowest. You'll just have to switch the first and the last and all that and that stuff to be able to do that. So, sweet. Thank you for watching. Have a good one. Bye.